All right, ladies and gentlemen, so today we're going to be taking a look at some uses of these exponential equations. And we're going to solve them, and we're going to look at some graphs of them as well. So as a reminder, our general form is y equals ab to the x. And a can't be 0 and b has to be positive, so it has to be bigger than 0. All right, so a population of wolves in a country is represented by the equation, and where t is the number of years since 1998. Predict the number of wolves in the population in the year 2008. So t is going to be 10 years because it's 2008 minus 1998. All right, so that's how we got the 10 years. So now I'm just going to put that into my equation, and I'm going to do some calculator work. So we're going to have 80 times 0.98t, right? We always start with our formula or our equation. So 80 times 0.98 to the 10th. And when you put that into your calculator, you're going to get 65.36582. Sometimes these problems are going to tell you to round. Sometimes the rounding is implied, right? We're talking about wolves, things that you can't have part of. So we would round that to 65 wolves. Okay, now what we're going to do is we're going to put it into our calculator. So I want you to put in your equation, just like it says here, into y equals, oops, sorry, we need to put this one, because we need, no we don't, oh my gosh, we need to put this one in, put in y equals, all right, making sure that the 0.98 is in parentheses, so you're going to enter it just like we did there. And then you're going to have to graph it. But before you graph it, we have to change our window, okay? So in our window, these are going to be the smallest t-value and the largest t-value because we're talking about time. Well, the smallest you can have is 0 because you can't have negative time. And our largest right now is going to be, we're looking for 10 years. We want a little bit more than that, so I'm going to say 15 years. You also have to say what you're counting by, which is the next line here, and we can go up by ones because 0 to 15 is not that bad. All right, the smallest value, so this is talking about years. These are talking about the number of wolves, right? Well, again, you can't have negative wolves, so that would be 0. Right now, we know that we start with 80, right? That's what this is. This is the initial amount. We'll talk more about that in a few lessons. So I'm going to do 80. Well, going from 0 to 80 by ones is not very convenient, so I'm going to put that we're going to increase by 5s. Okay, then we're going to press graph. So you're going to see this beautiful graph. What we're going to do, though, is now we can check this. So to check it, this is what you're going to do. You're going to hit the second and then the trace button. Trace is up top. You're going to do number 1 value. And then when it says x equals, you're going to put in 10 because that's what we were using. And what you'll notice is that if you did this correctly, you are going to get the same answer, which you would have to round down. Okay, so let's talk about the next problem here. So Daniel invested $500 into a savings account. This is your initial amount. The equation A equals, and there it is, models the value of Daniel's investment after t years. How much did his investment, will his investment be worth in 8 years? So this is t. So again, I'm going to start with my equation. A equals 500 times 1.005 to the 12t, so 12 times t. I'm going to substitute in 1.005, 12 times 8. This would also, I would put that in parentheses as well, because otherwise your calculator is going to do 1.005 to the 12th and then multiply that answer by 8. So you want to make sure that this has to go inside parentheses. When you do that, if you do it correctly, you get 807.07135542. We're talking about money, so again, this is implied rounding because money is always taken to the nearest penny. All right, in our calculator, so you're going to put this into our calculator. All right, this is what's going to go in into y equals, making sure that the 12t is in parentheses. All right, then, and of course, you're going to use x, but whatever. So our values. So these are years again, and we can't have negative years. We have to go to at least 8. We're going to go a little bit past that, so we're going to go up by 10. Money, right? This is now growing. If you notice, right, it's getting bigger. So my Y minimum is 500. That's the least amount that it can be. And our maximum, we'll take it to 1,000. But I would, so this is money, or value. But for this one, 500 to 1,000, I would go up either by 50s or by 100s, either way. And when you do that, and you do, again, we're going to do second trace value, x equals, but this time x is going to equal 8. And it will tell you that you get the same answer if you did it correctly. That's always the key. This is why it's a check on the calculator. All right, let's do another one where we're not going to necessarily put it into our calculator here. So a population of bacteria in a culture increases according to the model, all right, where T is the number of hours, and T equals 0 corresponds to 9 a.m. So use this model to estimate the number of bacteria at 11 a.m. Well, from 9 to 11, that means T is 2 hours. That's what we're going to be filling in. So doing the math, 300 times 2.7 times 0.02 times 2. So again, that's going to have to go in parentheses. I forgot to write the equation, sorry. When you do that, you get 3, 12, 1, 5, 8, 9, 601. But again, you can't have part of a bacteria, even as small as they are, so 312. Graph using the calculator. Name the p-intercept, which really means y-intercept, but since they named the equation starting with a p, and describe what it represents, and describe a reasonable domain and range for this situation. Well, p-intercept is when t equals 0, and it's your initial amount. So if I fill in 0 into my equation, 300 times 2.7 to the 12 times 0, 300 times 2.7 to the 0, anything to the 0 is 1. So P of 0 is 1. That's your y-intercept. It's your initial amount. Okay, let's talk about minimum and maximum here. So in my window, right, we're talking about time, and you can't have negative time, so that's 0. For the maximum, we went to 2 hours. We have to make it a little bigger. I would go by 3. Minimum and maximum. So my minimum, this is the number of bacteria. I forgot to write time. So I have, the smallest I can have is 300 because it's increasing, right? Right up here it said increasing. Maximum, well, we already went to 312, so I would maybe go to 350 because it's not getting that big. But again, you might want to go up here by 10s or 5s so that you can see what's happening. All right, reasonable domain and range. Well, we're going to write this in step builder. I know a couple we've done in interval notation. We're going to practice set notation. So reasonable domain for time. Well, again, time can't be negative, which means time, t, all t, such that t has to be greater than or equal to 0. Explain, time can't be negative. Reasonable range. Range are your y values. Those are your x, these are your y. X was talking about time, y is talking about the number of bacteria. Well, again, we're going to use P because they said population. And we know it has to be at least 300, and then it's going to keep increasing from there. So P has to be greater than or equal to 300. It's starting at 300 and increasing. So a lot of this is calculator work and getting comfortable with calculators and knowing what to change your window to, because otherwise you're going to put, if you hit graph, it's not going to show the correct curve, or you're not going to be able to see everything. So any questions, bring them to class. Make sure you have your calculators as you're doing this one. I should have said that at the beginning, so that you can follow along. Any questions, bring them with you.